Hello everyone, welcome back to Advent of Code. It's 2020 and we're doing day 24 today, but if you're watching these as they're published, today is Christmas, so if you're into that, Merry Christmas. Okay, let's get started on day 24. Day 24, Lobby Layout. Your raft makes it to the tropical island. It turns out that the small crab was an excellent navigator. You make your way to the resort. As you enter the lobby, you discover a small problem. The floor is being renovated. You can't even reach the check-in desk until they've finished installing the new tile floor. The tiles are all hexagonal. They need to be arranged in a hex grid with a very specific color pattern. Not in the mood to wait, you offer to help figure out the pattern. The tiles are all white on one side and black on the other. They start with the white side facing up. The lobby is large enough to fit whatever pattern might need to appear there. A member of the renovation crew gives you a list of the tiles that need to be flipped over. Each line in the list identifies a single tile that needs to be flipped by giving a series of steps starting from a reference tile in the very center of the room. Because the tiles are hexagonal, every tile has 6 neighbors: east, southeast, southwest, west, northwest, and northeast. These directions are given in your list respectively, like so. A tile is identified by a series of these directions with no delimiters. For example, ESENEE is east, southeast, northeast, east. Each time a tile is identified, it flips from white to black or from black to white. Tiles might be flipped more than once. Because in a hexagonal grid, there's more than one set of direction. In any grid, really, even if it were like am I thinking of Cartesian? No, because this is still Cartesian, sort of, right? It's just a different coordinate system in it, because I don't know. Oh, it's still Euclidean, but it's not Cartesian, is that right? I think so. Anyway, there's multiple ways to get there. For example, northeast, southwest gets you back to the reference tile and just does like going east and then west. Simple example, right? Okay, and so we're just supposed to go through all of them and count how many are black, which is basically how many toggle an odd number of times. And I'm gonna look up, I want to share with you guys a cool article I read some time ago, which I remembered when I read this originally, about how to represent hexagonal grids, kind of designed, I think, for like game designers, but in principle, anyone who needs a grid. And it's actually a real cool interactive article. So you're like, oh, actually, I have like flat topped things, and like rotates all. It changes the discussion in the rest of the article for you, whichever one you use, and you can change perspectives either way. And it talks about like angles and stuff, which I don't really care that much about. But coordinate systems, right? This is kind of an obvious way that people think of. There's a lot of ways to represent coordinate systems in like a computer memory, right? To represent hexagons, a coordinate system for hexagons. And these are kind of natural things that people think of, but this article argues not very good for most of the things you might want to do with hexagons. Rather, it's much better to work. I don't know. I find the cube coordinates make a lot more sense to me. We're going to use axial coordinates actually, which are like a slight sophistication on cube coordinates. But what's cool is in a normal 2-dimensional square grid, you have 2 primary axes, north-south and east-west, and you can kind of take moves that go along those axes, and you can basically just, if you add together some amount on the north axis, some amount on the east-west axis, and that gets you a square. And as long as you don't have the same 2 total amounts, that's uniquely identifies a square. That's not true in hexagons. In hexagons, you have kind of like 3 major axes, right? You can start from the center and you can go northwest. You can go some amount on this axis, some amount on this axis, or some amount on this axis, or like this, right? So there's 3 axes. I think I said this one twice. And it doesn't uniquely identify, because you can go this way once and this way once, which is the same as going this way once, right? And so that's sort of problematic to have non-unique representations. But it points out, what if you take a slice out of 3D space? So basically a plane. Is it a plane? I think it's a plane. A plane that you cut diagonally through a cube. And that's sort of what this diagram is trying to give you. And since there are 3 axes, right, a cube has 3 axes, and it's very natural to think of moving along one or two directions. And if you do that, and you make like your plane is represented as, well, not represented, it has the effect of giving you you can define a plane by setting an invariant that should hold, namely that x plus y plus z is all 0. That's kind of how you take a plane sliced through the 3-dimensional space that is laid out in some way, and so you can see that if we do that, we say, this point has 0 on some axis, -2 on another, and +2 on another, and if you move along any one axis, you can see that as you do so, you're maintaining this invariant, but you're not necessarily changing only a single coordinate as you go. In this example, they've laid it out so that this dimension is, I don't know, the z dimension, I guess? Yeah. And when we go along this, we just increase or decrease z by 1. No, we don't. Hang on. Which one is actually staying the same? Oh, none of them, of course. Because anytime you move along one axis, you have to change another axis to maintain the variant that x plus y plus z equals 0. So when we move this way, we're increasing x but decreasing y. In this direction, we're increasing y but decreasing z if we go this way. And finally, in this dimension, we're decreasing x and increasing z. And this has the nice property that no matter how you get to a place, whether I go like west, southeast, or just southwest, you arrive at exactly the same coordinates. And so you can use that for oh my gosh, help my brain. You can guarantee having unique coordinates makes things easier. Computing distance between any two is actually just like subtracting their coordinates from each other. As I recall, right? It's like Manhattan distance, but on this XYZ triple. For example, like what's the distance from, say, here to the origin? Wait. Is the distance just the largest of any one coordinate? I think it is. Here it would be 3, right? Yeah, if we go around the grid, we notice that in anywhere along the edge, there's a 3 somewhere. The inner circle, there's a 2 somewhere, but no 3s, and so on. And if we look at this, if we look at like distance somewhere, distances, the distance on a hex grid. Oh, right. Yes, of course. So that's the distance from the origin. But the distance for between any 2 points is a little bit like Oh, I spelled distance wrong. That's why I wasn't going. Yeah, so distances are simple. And right. So you compute the differences between the two independently and combine them by adding, just like Manhattan distance on a square grid or a cube grid. But since we're changing 2 dimensions every time we move instead of just 1, the distance is actually magnified from what it should be, and so we divide by 2 at the end. Or to notice that one of the 3 coordinates must be the sum of the other 2. And then picking that one as the distance? What does that mean? Well, if you were to subtract the 2 coordinates from each other, yeah. If you subtracted the 2 coordinates from each other, then point-wise, right? You would end up with a 3-tuple, which is sort of like a delta O coordinate, and one of the digits would be the largest, and that would be the one that's how far away you are. Sure. And so we're going to use axial coordinates, because a problem with cube coordinates, there's nothing wrong with them. They're great. But it's possible to represent coordinates that are wrong, right? There should never be a coordinate that's like 1, 1, 1, right? But you can represent that using cube coordinates, even though it's not on your hex grid. And Haskell programmers love to make illegal states unrepresentable. So, we are going to let the 3rd coordinate be implicit. Specify 2. Specifying any 2 coordinates uniquely identifies the 3rd, or 2 dimensions identifies the 3rd, right? And so this article calls that axial coordinates, where you just specify 2 and let the 3rd be implicit. And so for distance between 2, if we end up needing that in part 2, for example, you just like materialize the 3rd coordinate temporarily. Okay. So anyway, I just wanted to like talk some about this and explain with nice pictures how our coordinate system today is going to make sense. Okay, let's get started here. And I think we want to do a couple of things. We want a new type axial coord is an axial coord of 2 ints. And I choose new type here because I want a few things to be derived. Oh. Sum of int and sum of int? Sure. Gonna have to import sum. Data monoid sum get sum. And it needs to derive like ord eq, because we're gonna be putting these in a map, right? Or a set or something, probably a map, yeah. And monoid semigroup. Is that all I need? Of course, my process has died again. Oh, whoops. It's editing date 23 again. Okay, it's gonna tell me I need to add like new type deriving or something. Generalized new type deriving, yeah. It actually, I like that it'll autocomplete for me there because that string is present in the error buffer. That's kind of cute. Oh my god. Would you stop dying on me? I should look at the error message and see why it's broken. It's probably about text regex applicative again, right? Stack build. Interesting. So it's like stackage was updated or something? I don't know. Okay, so it builds. Okay, fine. And so we talked before about how pairs are monoids pointwise, right? If you have a pair of x and y and you add it to another pair of x and y, you add the x's and add the y's. Ints form a monoid under addition. But they also form a different monoid under multiplication. So you have to specify with the sum or product new types of which one you want. I think it's cool to use sum, int, and stuff. And here it's going to be useful because now we can, like, instead of having to implement a fold ourselves, it adds together points by coordinate or whatever. We can just use mconcat and pass it a list of coordinate or of axial coordinates, and it'll give us back an axial coordinate that is their sum. That'll be the result of following all the directions. So that seems pretty cool. Now, another thing that I want is we could just use true and false in as the values of our map, but I think it would be better to have data color equals black or white. Just for, like, actually let's use white or black. Oh, that feels very unnatural. The grid starts out as white. I guess I'll derive eq because I want to be able to say is the color black, and doing so without writing a pattern would be nice. And we're going to need data map. Data map strict map import qualified data map strict as m. And we're going to build a map from axial coordinate to color is the idea. Okay, but we need a few things. We need to be able to parse, right? That's kind of a little bit interesting, but not very. We'll use text regex applicative for that. And so what we want is, I think, to just define our coordinate system, or the 6 directions in our coordinate system as values of the type axial coord. So west, east, northwest, northeast, southwest, and southeast are all axial coords. West is... So now we have to decide our dimensions here. Now, shouldn't there be some... Yeah. So we could just define, for example, the east-west axis to be our first coordinate. And then define, say, the northeast direction to be our second coordinate. And the northwest direction can be left implicit, for example. It's sort of arbitrary which we do. So west is axial coord of -1, 0, say. East is axial coord of... I could eliminate all these axial coord wrappers if I wrote, if I wrote a list of 6 things, mapped axial coord over them, and then pattern matched them into a 6 size list, but that seems kind of gross. These are important enough to deserve their own top level definitions, I think. And east is 1, 0. Northwest is... Actually, let's put them in the proper order. So the 2 that are opposites of each other are next to each other. Northwest and southeast, northeast and southwest. So this will be 0, 1, northwest chosen arbitrarily. Southeast is axial coord of 0, -1. Again, I'm just -1, please. All right, now the third one is more exciting. We're going to be increasing 2 of these directions, right? I guess I should define a cube coordinate because I'm going to be maybe translating those at some point, although maybe not, I don't know. Northeast is axial coord of, and this is sort of the confusing one. So, oh, actually, by happenstance, I happen to arbitrarily choose the axes that are the same as the ones in this diagram, right? East is increasing the first one. I wasn't looking at the diagram when I made this decision, I don't think. Northwest is the second one, and I don't know, they chose northwest to be negative in that direction, so I guess we might as well do the same. And then so to go northeast, I can do this without looking at the article. To go northeast, we just add together a northwest and an east. And so I was going to do that manually and say, like in my head, okay, well, northwest is 0, -1, east is 1, 0, so it should be 1, -1, right? But we can actually just say northeast is west, or yeah, it's northwest plus east. Southwest is southeast plus west. And so the fact getting this plus operator is why I think it's nice to have axial. Oh, let's put show in here as well, I suppose. Why I think it's nice to have a new type and a sum instead of like dealing with positions manually. So let's just test this much real quick. What exactly is northeast? It's 1, -1, exactly what we said it should have been when I said go northwest and then go east, right? These two added together give you 1, -1. Cool. And now that we have the 6 values we care about, it's pretty easy to write a parser. Our input is going to be a list of axial coordinate. import from maybe again, or yeah, that's fine. Import data maybe from maybe, where parse is match path, say. Path is many it's not just actually I should not just traverse parse. I should really so I want parse to return actually not just a single coordinate, but the list of steps we took, just in case that ends up being important, and then I'll mconcat at some later time. Map mconcat, say here. Path is then just many coordinate, and coord is one of 6 things, right? It's a sum, which is a choice of a list of things, a sum of let's say label direction, or label, no, other way around, coord label for coord label in labels. And labels is a list that we will define by hand of tuples. Oh, actually, let's flip these. It sort of feels more natural to write the label first. So we will say east is east, or west is west. Northeast is northeast. Northwest is northwest. Southeast is southeast. Good guess, Emacs. And southwest is southwest. Yeah, I do want asum from foldable. I forget where the hell asum is. Haskell asum foldable. Okay. It goes here. Import data foldable asum. RE-char list of axial coord is what I want here. So which part is wrong? So this part up here is right, of course, that makes sense. Okay, and coord RE-char to a single axial coordinate. Yeah, now it's saying path is right, of course. What does this error mean? In the expression, what expression though? Please give me back my FlyTech error messages. In the expression, nothing? Come on. Stack build. Look at the real compiler output. Okay. So what it's actually saying. Label is wrong, of course. I didn't actually put in the stuff for parsing. String label? Core shadows the existing binding from who knows where. Actually, from where? Oh. Yeah, that's fair. It's here. Probably shouldn't use it use a name that's the same in its own definition. This would work. We're shadowing it, and that's fine, but it seems extremely confusing. Dir, let's say. And so now we can like test, does this work? Prepare of, you know, east, southeast, southwest. That gives us 0 in one axial direction and 2 in the other. And if we look at the map, we can see, is that right? We went east, southeast, southwest, and we ended up at 0, 2. Perfect. And of course, if we do the same, if we put a new line in here and then say, well, let's just go east, then we get another one that says 1, 0, which is what we wanted. Okay. That seems pretty good. And I think the rest we should just write as part 1, basically. I mean, should we even have black and white as colors? I guess so. I might want them. I was thinking we could just have a map to like int, which is the number of times toggled. That's actually honestly sort of easier. Okay, fine. We'll do that then. So part 1. Is the length filter odd? That exists, right? Yeah. M elms of m dot from list with plus of, I don't know, let me look at Haskell data map. What are other ways of creating a map? Am I doing it a dumb way instead of a smart way? Construction empty singleton from set. From set would kind of be nice because you can just compute a function and I could use a constant function. But I guess I don't know. It's not so hard, not so bad to write flip. No. Map once, where once of chord equals chord 1. There you go. Why are you mad about odd if you don't know what int to use? Yeah, that makes sense. I don't care though. Yeah, so we say each coordinate should be flipped, and we build a map from those lists, adding together any duplicates, and then we just look at the elements and take only those that are odd and count them. That sounds good. Stack, run. $312. Okay, I'll take it. I mean, we could do a quick, like, just, is this answer completely ridiculous? No, we have 392 lines, so it's not like we somehow got more than that number. And we got, you know, a quarter of them conflicted. That seems about reasonable, a little less than a quarter. Let's test it out. 312. That's the right answer. Great. I guess there's a couple things to clean up here. I'm not using getSum. That's kind of funny. Sure. I'm not using data map strict yet. Because the map type is all implicit in just part 1. That's kind of funny. But I'll probably need it for part 2. We're not using lambda case. That I agree with. We're not using applicative do either. Because asum is kind of all we needed. All right. Day 24, part 1. All right, let's see what's part 2. The tile floor in the lobby is meant to be a living art exhibit. Every day, the tiles are all flipped according to the following rules. Any black tile with 0 or more than 2 black tiles immediately. Okay, so it's the game of life in a hex grid. Any white tile with exactly 2 black tiles is flipped black. Yeah, makes sense. So we start with our part 1 input, or part 1 output, really. Okay, cool. So now we're kind of unsurprisingly being asked to have like the colors modeled rather than just like number of flippings, which is fine. So I'll go back and define that color that I had sort of removed. Data color equals black or white. Deriving eq and ord, I guess. Eq and show, I mean. I probably don't need the eq instance, but like, it's fine. We'll define a couple functions to work with colors. Flip is a color to color. Flip black is white. Flip white is black. And they're asking us to like count the number of black tiles, basically. Yeah. Well, I don't need eq then, really. Just show is fine. And we'll just define the function is black, or black, color to bool, black is true, black, white is false. So I think that we should take like this and make it a separate function. Seed, let's call it. This function from input to map chord color, axial chord. Seed equals like this, right? Yeah, plus is wrong. Flip. Start. I don't know. Oh, from list width is not quite right because we don't have a way to combine two colors. Which is, it sort of points out that this is not, from list width is not really right because okay, I think I want to make a bunch of singleton maps and then union them all together with flip is a sort of more meaningful, domain accurate way to do it. So, like there's unions is what I want, right? Unions with, yes, takes a function. Oh. Yeah, I guess in either case I need a way to combine two things, don't I? Okay, well we'll just define a simple little combine function then. Not flip, but combine. I won't actually need flip, will I? I don't think I will. Combine of black and black is white, and combine of equals, I'm sorry. And the other way to get white is white and white. Combine any two other things, and you get black. We decided to call this start. Okay, and let's check that we still get the right answer for part one here. Great. Day 24. Switch to coloring. Cool. So now we just have to like implement neighbors and game of life again. And it is certainly possible that it will fall outside of our grid, which is fine because we're not representing the grid at all. We just have a map from coordinate to color. But oh, this is fine. How did I do when we had like Conway's cubes? We used like an actual array and we increased the size that we were looking at by 1 each generation, right? The Conway hypercubes or whatever. Oh, that reminds me. I don't think I showed this on camera at all. Actually, this is easier to do in Emacs. Looking for cube in here somewhere. This is not as helpful as I thought it would be. Here we go, day 17. I did generalize this to arbitrary n-dimensional spaces instead of just just 3 and 4, in a way that I kind of talked about that we might do on video, but I hadn't actually done. So if any of this is unfamiliar to you, you know, go back and look at the day 17 video. But basically, we had a cube game of life, and then we had a hypercube game of life, and I had special case 3 and 4 dimensions. But talked about, wouldn't it kind of be nice if a tuple of int to any coordinate was itself a coordinate? And so I did that. I have a vec2, which is a pair of ints. Although, do I even use that? I must, right? Oh, I see. The input is parameters. Yes. Because the original seed is given to you as a 2-dimensional array, but then you need to interpret it as a 3 or 4-dimensional space. So I said anything indexable is valid for a coordinate if you can just define the neighbors for it, and you can add a delta to it. So that we can increase the size of the bounds. And then for ints, of course, you just add them together. And to find the neighbors of an int, you just say the int itself and the one below it and the one above it. And if you have a thing that can be coordinatable and another int dimension, you can just add the n that you're given to each of its dimensions recursively. And for neighbors, you can compute the neighbors of the lower dimensions and choose a delta of 0, -1, and 1. And then add that delta to the dimension you're currently working with, but leave the other dimension alone. And so there's this nice little next dimension thing that tacks a 0 onto the front of something. And the whole like tick thing gets to remain completely unchanged. It just needs coordinacy, which I guess it already had at the end. And it was actually kind of nice. You could just say part 1 is, you know, fmap next dimension. So lift each tuple, each coordinate from the second to the third dimension, and then run. Here you can say map, go from second to third to fourth dimension, and you can actually do it in like the 5th dimension, and it's fine. It takes like a little while because it's a pretty large array. But we're doing it in ST, so it's like, I don't know, it took less than a minute, I think. Which is not bad, considering that it was like, I forget exactly how many, but it was pretty large. Tens of millions of items anyway. So, all that to say, what exactly? I was just wanted to revisit, like, how did I handle that when I didn't know the bounds of the grid? And here I could do something similar, where I find the initial bounds by like looking at our seed and seeing what is the largest it is in any of 2 dimensions. Am I like... I think I should define a way to compute the neighbors of a tile. Right? Oh. I mean, I kind of have that already, don't I? Let's say axes is a list of axial coord. Axes, or ders, I don't know. Ders is just west, east, northwest, northeast, south, southwest, southeast. And then we can say neighbors is a function from axial coord to list of axial coord. Neighbors of C is the function adding C mapped over dirs. So pick a direction and add what you've got, and there you are. And that's our neighbor function. And I think what we want then is a function from like a list of axial coordinates to min and max bounds, that those for the space defined by those coordinates. Yeah, that seems fine. Bounds, because I want to know which squares I need to look at it for the next generation. So bounds is a function from list of axial coord to pair of axial coord. Well, I mean, technically, it's a function from non-empty list of axial coord, but we'll just assume we never get given an empty one because we won't. Anyway, axial coord, axial coord. So bounds C's equals axial coord of min x, min y, and axial coord of max x, max y. Oh, we can be so smart here, I think. Where can we be smart? I've done this in a previous year where because minimum and maximum kind of follow a semi-group structure, and monoid is like just an enhanced semi-group. And if you can yeah, I think we want this from, where are min and max? Are they data semi-group or data monoid? Haskell data semi-group. So we have all this S time stuff. Yeah, so min is in semi-group. And so is max. And so the idea is to use fold map. Well, fold map wants a semi-group, but I bet data monoid has some function for like fold map with a default or something. Or oh, I guess what we want is a semi-group to monoid. It's not really what we need here, is it? And oh yeah, there's all these wrappers for things. That's not really what I want. I want like, it's got to be in data semi-group, right? First or something. Option. Data monoid has first, which is a maybe of A. Use of this type is, yeah. Oh, it's a maybe of a semigroup of first? Oh, I just want a maybe of my min-max tuple? Yeah. Okay, I don't know. This is all like more work than just doing it by hand, but I like trying to understand how what I'm doing fits into the more like abstract structures. So we'll say that just we'll make a pair min I'll have a pair of two coordinates. Sure. Min x, min. Is this right? Do I want the x's together or the y's together? I think it, or like the mins together. I think it doesn't really matter as long as I'm consistent. Max x, oops. Max y equals fold map min max, let's say, overseas. Oh, I need min from data semigroup. Min max. Oh, and I need its constructors as well. And min-max of an axial coord xy is just a pair of min x, min y, and max x, max y. Ah, right, this is a tuple. So let's see, that seems about right. Let's test it though. Bounds of, I don't know, west, 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 and northeast, east? So what did that give me? It said that the y coordinate, or the x coordinate, goes from -3 to -1. No. The lowest y coordinate is, the lowest east-west coordinate is -3. And the lowest of the other coordinate, whatever, is -1, which I assume is north. And the highest x coordinate is 2 when we went northeast and east. And the highest southerly direction is 0. So this looks right to me. And I just think it's so cool that, you know, if you have a list of tuples, like, it's kind of obvious how to, if you wanted to compute minimum and maximum of both dimensions, you could create a list. You could loop over it 4 times, for example, would be one thing you could do. Or if you were in a mutable language, you could iterate over it and each time update 4 values with min and with max or whatever. And it feels non-obvious how to get that same efficiency in immutable language, where you can't just do 4 things. You can write a fold that takes a 4 tuple and updates that, and like that's fine, but it sucks to write, doesn't it? Here we can just use fold map and say, I want, what I'm folding over is a maybe of tuple of 2 mins and 2 maxes, or tuple of 2 mins with tuple of 2 maxes, and the combining function for those is just like, it's handled, it's written. Everyone knows how to combine a maybe of a tuple of mins and a tuple of maxes, right? Like, how cool is that? Anyway, so we have our bounds now and our neighbors, and I think that means we're just about ready to write step, which takes a map from coordinate to color and gives us a new map from coordinate to color. Because we can just build a new map it turns out we don't ever need the cube coordinates at all, because we don't care about distances. We can build a new map. Yeah, that seems good. So let's do that then. I don't know, let's move this input type to the top with all the other types. There you go. So now, step is a function from map axial coord color to map axial coord color. Step of m equals something. And I guess it's just m dot from list of like computing the new bounds, basically. Let's say from list of do, because I always hate writing list comprehensions. I wrote 1 in today's program, which is more than I usually write, because it seemed fair. Oh, did I write 2? I have 1 here. No, I just wrote 1. Okay. We'll let axial coord min x min y and axial coord of max x max y be, oh, you know what? Why am I unwrapping stuff here? Why am I wrapping stuff in axial coords just to unwrap it later, right? Why not just return this? Yeah, and say its result equal bounds of m. And so now it's like a little bit tricky, but we're returning instead. And this, by the way, is nice because it like it keeps the fact that I don't know. I guess it doesn't really matter either way. So it returns what? I don't know. We'll just let the type checker tell me. It should be min of some int. What? Oh, I see. Yeah. So here's our actual type. Can I get into that buffer? I can, thank goodness. Just give me this. There you go. It's a little ugly, I agree. But it clarifies that the mins are in the first tuple and the maxes are in the other, rather than like the x's going from low to high being in one. Oh. No, it doesn't matter. Yeah, that's fine. So why is M still upset? Oh, bounds of M elms. Ah, no, I shouldn't be computing the bounds every time. I should compute it ahead of time. Oh, yeah, yikes. I should probably give this a type then, right? I'm going to use this more than once. Type bound equals that. Bound. There you go. Because this needs to take a bound. And actually, I think it's returning a pair of bound. Maybe it should be, oh god. It really should be like this, yeah? This map type is looking kind of like it should be named something. Type grid equal this. And we actually now have there you go. Oh, we have an M dangling it. No, that's... Oh, I see. Right. This is how we're destructuring the bound, and then at the end we have an M. Okay. And it'll be... We'll say bound prime M prime, where bound prime equals min of min x minus 1, min of min y minus 1, max x plus 1, max y plus 1. And we'll then say M prime equals, okay, I have my parentheses missing somewhere. Cool. So now it's all back to type checking, but we still have to implement stuff. Let's say that x comes from kind of hate this. Min x minus 1 up to max x plus 1. Y comes from min y minus 1 up to max y plus 1. I wish I knew, like, what? No instance for enum of sum of int? Really? I hate that. I guess it makes sense. Why should sums of things be enumerable? They could be, but it doesn't make sense for them to, like, have it derive every new type you could possibly want, right? Or every instance. Okay, fine, you got me. Sum over that. Get some. Get some. I'll have to import these in a moment. There you go. Now we need to let ends equal well, let's let this equal m dot okay, let's let a coordinate be my thing, I guess. Home, we'll call it C. Axial coord of x and y. Look up C in M. Ends is map over neighbors this. Color? Oh, neighbors is C, of course. So it would actually be a bit cleaner to say let this ends equal like so. And now we look up both this cell and its neighbors in the map. And we'll say the new color is num black. Right, this is defined in terms of black. Black is living in this. Is that right? Doesn't really matter. But the rules are defined in terms of how many black tiles are adjacent. Num black is length filter black ends. New color, which we'll just call color, is case color and in case this num black of so if this is black, 0 or more than 2. Black n where, I don't know, we'll just write the rules down by hand. 0, then it becomes white. Black, n where n is greater than or equal to 2 is also white. If it's white and there's exactly 2, then it becomes black. Otherwise, it's old color. We just return unchanged. That's how we transcribe these rules, right? If it's black and it has 0 or more than 2 black tiles, then it becomes white. If it's white and it has exactly 2 black tiles, it's flipped black. Otherwise, we leave it alone. That's what we've written here. In now we can finally say pure of axial coord. Oh, pure of C. In fact, we already have that. C color prime. It type checks. Incredible. Why is this yellow? What are you upset about here? Oh, it's inexhaustive, I suppose, right? Sure. But we can clearly see that it will work. If we were using non-empty, then the compiler would believe us, but we're not. Okay. So I think part 2 then is done. What's it asking us to run 100 times? How many of them are black? It's length filter black elms second, because we're ignoring our bound. Hang on. Where was I computing the bounds? I have bounds here. Okay. So I think I can just say go 100 generations, iterating step. But before you do, we have to get the bounds and the map, right? Which is just bounds seed, like so. It type checks. Incredible. So remember, we use this triple and in the main every day, but like, you don't really think about it, right? It's some arrow shit. I don't understand arrows at all. But I do know that when you use the arrow instance for functions, this triple and operator takes a tuple of functions and applies both functions to some input. We could do this with like the monoid instance of the applicative instance with functions instead, but like, since this exists, why not use it? It's a little more convenient. So anyway, that's what this triple and is. And so we're saying, take the list of coordinates you were given, and that's our input, and compute its bounds and a map for it. Then iterate step 100 times, get just the resulting grid, and then count the number of black elements. Error. Yep, you got me. That makes total sense. I know exactly what that error comes from. I forgot that the thing might not be in, so I shouldn't be using just m.lookup. I should find with default. Takes the default, and we'll just say white is the default, right? We'll just call the function get, why not? And we're looking in the old map, right? We're doing it with the default, which is fine. Okay, get OC is m.find with default white CM. Okay. $1,532 seems plausible. Not the right answer. Too low. Too low. Okay, we should probably use the test input, I guess. I assume there is one somewhere. Yeah. Sure. Well, we'll just take our example input here. And add example.text, like so. Hang on, I did, yeah, I updated the bounds, that's fine. So let's just read example.text instead. And what is it that they're doing in the example? We can say, like, first of all, let's just go like 0 iterations. How many are in the original list? That should be the same as day 1, right? It is, okay. And if we go 1 iteration, we'll be wrong, I assume, somehow? It's still 10? That's not good. It was supposed to have been 15 according to the example, the worked out example, and then it goes to 13. Okay. It's a little bit tough to visualize how to debug this, right? It would be nice if we could draw the map and like see what went wrong. Instead of just like, well, I did the result and the answer is wrong, Chief. Great. Amazing. First off, let's make sure I handled all the directions. I didn't duplicate one. You had northwest, northeast, southwest, southeast. Yes, that's all of them. And I think neighbors is right. I guess we could test that real quick. Neighbors of, I don't know, southwest. Seems plausible. I don't know, let's just do neighbors of west, which is probably a little easier to visualize. Yeah, you could go to you could go west-west, or you could go like west-east, or you could go west-northeast, or whatever direction is my other primary axis, I forget. Anyway, this looks fine. So I guess the simplest thing that I could have wrong is that I might have transcribed the rules for flipping incorrectly. But I don't think I did. Let's look. It's here. So it says any black tile with 0 or more than 2. Oh, yep, that's the problem. It doesn't say 2 or more, it says more than 2. All right, let's try that again. $12. $12 is what is correct for after going 2 days, and after 1 day, it should be 15. It is. Okay, so let's just do one last check on the example input before we go back to our real input. 100 should yield 2208 according to the example. And it does. Okay, great. So let's say our real input then. $3,733. This is larger, and that makes sense because I made it more difficult for a black cell to become white when I fixed the bug that I saw. 3733. That's the right answer. Thank goodness. All right, that was a fun one. I liked having an excuse to work with like both cool hexagonal coordinates and also cool monoid and semigroup instances. Anything I should like change first? Probably I should make this a function, right? But I don't know what to call it. Next generation or something? It's kind of just like step, but for a single thing, right? Let's just leave it alone. But part 1 could really be just like run a number of generations. So we'll say run takes an int and produces a function from input to int. Run n equals that. Part 1 is run 0, part 2 is run 100. And if we do this, we should still get the same 312, 37, 33, right? Yeah. And just happily, making this a bit shorter means that it doesn't exceed the 80 character boundary. So isn't that lovely? Oh, I have a 90 character wide window? Fucking bizarre. I thought it was an 80 by 24, but I guess I changed my default settings somehow. Okay. And that's fine. I don't mind like 100 character lines. Any longer than that, I get a little upset. But okay. This information about how things are textually represented lives inside of the parser, which makes sense. Honestly, this really is the only thing that bugs me. So let's just fix it. New color is a function from color int color. Color well, we'll just write the whole thing out. Translate from case syntax to function mat here. Color white 2 equals black. Color anything that should be an equal sign. And now here I just have to say color prime. I don't even need to name it anymore. It's just what do I call it? I just called it, oh, it was supposed to be new color. Okay. New color of this num black. Okay. Now I think I'm reasonably happy with this. I have the only language extension I need here. It's not warning me about any unused imports. You know, it kind of, since I have these directions anyway, it would have been nicer, after all, to define them in a different direction, I think. No, because like what I could do is now say, you know, west, east, northwest, southeast, etc. equals dirs, and like that would be okay. But I like having the directions be the primary thing, and the like each direction be its own top level thing, and to just derive a list of them. Yeah, I kind of hate this bound type. I'm sure there's something better than doing this. Oh well. We'll have to live with that. Day 24, part 2. All right, well, tomorrow's video should be the last one. Day 25. Hope you guys are looking forward to that and that you enjoyed this one. Thanks for watching, and I'll see you next time.